Have you looked at the stars lately? For centuries, humans have gazed upon the stars, awed by their brilliance and comforted by their presence. Hello, and welcome to CUSU Science Update. I'm Marisa McNatt. Whether they were used for navigation or predicting the seasons, the stars guided the lives of our ancient ancestors. But when was the last time you looked at the night sky to find out how many days were left before spring break, or how soon to expect the first tulip to bloom? For ancient people, the night sky was their calendar, a calendar that meant the difference between life and death. The night sky told people when it was time to plant seeds, when animal herds would return, and when the riverbed would fill again with water. But the stars were also the stuff of myth and legend, points of light that represented departed souls or passages to heaven. To ancient people, groups of stars formed patterns in the night sky that appeared as animals, objects, or mythological beings. These patterns make up the constellations, shapes that are formed by connecting lines between stars, seen by ancient people as lions and bulls, herdsmen and plows, dragons and whales. To ancient peoples, the incredible number of individual stars made more sense when they saw them as groups of stars with definite shapes. When Greeks and Romans looked up at the night sky, they saw Orion the hunter, Leo the lion, and Cygnus the swan, names that are still used today. In North America, the Iroquois Indians saw a great bear in the sky in the constellation familiar to many of us as the Big Dipper. In the Middle East, the same constellation is seen as a pot or bowl. Like guideposts, constellations can help observers navigate their way through the night sky. Knowing constellations makes it easier to find individual stars. For example, the two stars at the tip of the Big Dipper's bowl point to Polaris, the pole star, which makes up the handle of the Little Dipper. On account of the Earth's rotation, Polaris always remains in the same spot of the sky, while the other stars appear to circle around it. In the southern sky, Orion is probably the most identifiable constellation that is visible throughout the world. The hunter in Greek mythology, Orion, is depicted wielding a club to fight Taurus the bull. Orion's most striking feature is the row of 3 bright stars that form his belt. Drawing a line through the belt from left to right will lead to Aldebaran, which is the brightest star in Taurus. And to the left, the belt points to Sirius, the dog star, which outshines all others in the skies above Earth. But no other constellation has as many bright stars as Orion. Serving as Orion's left foot is the blue supergiant Rigel. Over 500 light years away, this star is 33 times larger than our Sun and 20,000 times brighter. Because it takes light from Rigel 500 years to reach us, we see it as it appeared about the time when Leonardo da Vinci painted the Mona Lisa, or when Ferdinand Magellan left Europe to circumnavigate the world. Looking at Orion's right shoulder, we see a distinctive reddish star called Betelgeuse. This red supergiant is 300 light years away. It's 5,400 times our Sun's diameter and 3,600 times as bright. There are billions of stars out there, and over the centuries, many people have attempted to catalog them all. In 129 BC, the first well-known star catalog was produced by the Greek astronomer Hipparchus. He ranked stars from the brightest to the faintest and called the brightest stars of the first magnitude. Magnitude is still used today to measure the brightness of stars. Near 140 AD, Claudius Ptolemy used Hipparchus' system in his own list. Ptolemy's astronomy texts were used for the next 1,400 years, but Hipparchus and Ptolemy could only catalog the few thousand stars that could be seen by the naked eye. It wasn't until Italian astronomer Galileo Galilei turned his newly made telescopes on the stars that we discovered just how many millions of stars there are. Telescopes opened up whole new ways to stargaze. Not only can you see the faintest of stars, but for the first time, astronomers could resolve areas of the sky that looked slightly fuzzy. For example, as seen through a telescope, the fuzzy patch below Orion's belt becomes a luminous gas cloud. We call it the Great Orion Nebula. 300 light-years distant, this nebula is the site of massive star formation, a sort of stellar nursery. and it's one of the most scrutinized and photographed objects of the night sky. These days, it's hard for many people to see details in the night sky because of all of our city lights. But astronomy has never been limited to just the nighttime. The moon is often visible during the day, and the inner planets, Mercury and Venus, can frequently be seen around sunrise or sunset. Sometimes, distant stars are also visible in the daytime. Observations of supernovae that were visible during the day date back at least 1,000 years. But there's one star that is always visible during the day. It's the one that's closest to us, and the most important, the sun. For most of our existence, humans have charted the sun's path across the sky to know when it's time to hunt, eat, and finally to sleep. In Neolithic times, the sun was thought to traverse the sky in a celestial boat. In ancient Egypt, the sun was primarily identified as Ra, the sun god, who later merged with the god Horus. And in Roman times, sun worshipping gained widespread importance, which led to the Feast of Sol Invictus on December 25th, a time of great joy that was later recognized by Christians as Christmas. Ancient peoples followed the motion of the sun to mark the winter and summer solstice, when the position of the sun reaches its northernmost and southernmost extremes. And the sun's position also marked the spring and autumn equinox, when the tilt of the Earth's axis puts the sun along the same plane as the Earth's equator. As seen from Earth, the sun takes a path through the sky along what is called the ecliptic, and the constellations that lie along the ecliptic make up the zodiac. There are 13 zodiac constellations, which the planets, sun, and moon appear to pass through at different times of the year. At any given moment, the positions of these celestial objects have an influence on our lives. According to astrology, a belief system that has been around for 2,000 years, if not longer. Astrology says that if you were born at a certain time of the year, your birth sign, based on positions of planets and the stars, can be used to forecast your future. Any misfortune or accident was often tied to some celestial influence. In fact, the word disaster originates from the Old Italian word disastro, which means unfavorable to one's stars. Astrology is considered to be a pseudoscience, a claim or practice that cannot be supported by valid scientific methodology, which is based on gathering observable and measurable evidence. Today we see astrologers as fortune tellers and astronomers as scientists, but the distinction was not always so clear. For thousands of years, our understanding of the stars was shaped by storytelling as much as by observation. Almost all ancient cultures would come up with stories that explain the nature of the universe. Early Mesopotamian religions described the universe as a sphere made from the body of the mother goddess Tiamat. At the center was the earth, along with heaven and hell. Above lay the realm of the gods, who lived among the stars. The early Egyptians believed in the goddess Nut, whose body was covered with stars. She stretched herself over the earth to hold back the infinite chaos that lay beyond the sky. And an ancient Chinese legend tells us of a being named Pangu, who was born from an egg and pushed the earth and sky apart. When he died, his eyes became the sun and moon, and his beard became the stars. Around 1300 BC, the Chinese began making detailed observations of the night sky, and by 700 BC, the Babylonians were using their own records to make predictions of certain celestial events. It wasn't until about 600 BC that the Greeks began to dabble in astronomy, which comes from the Greek words for star and order. It was the Greeks who discovered that Earth was a sphere, and the philosopher Eratosthenes measured its circumference to within 200 miles of today's value. For 2,000 years ago, that's some mighty fine calculating. In 200 BC, Aristarchus was the first to state publicly that the Earth revolves around the sun. But from 100 to 170 AD, the Egyptian Greek astronomer Ptolemy said the sun and planets revolved in large circles about a stationary Earth. Ptolemy's work was accepted as the authority on astronomy for about 1,400 years, until a Polish astronomer published a study that caused an amazing amount of controversy. In 1543, Copernicus published his theory that all the planets, including Earth, circled around the sun. Although a tremendous leap for astronomy, the heliocentric system of Copernicus was attacked for being contrary to Christian beliefs. It's little wonder that people once thought our planet was the center of the universe. This made intuitive sense, since it appeared that everything in the night sky circled the Earth. But sometimes, the night sky would shake things up a bit. A star might appear to fall, surely a sign from the gods. Today we know that shooting stars are meteors, small space rocks burning up in Earth's atmosphere. Then there are the comets that would swing by Earth periodically. People saw their long gaseous tails as good omens or as harbingers of doom. Once in a while, a new star would appear, sometimes becoming so bright that you could see it during the day. The astronomer Tycho Brahe described these stars in his 1573 book, De Stella Nova, Latin for Of New Stars. Today, we refer to these brighter-than-usual stars as supernovas. They occur when a massive star literally explodes at the end of its life cycle. Chinese and Arab astronomers recorded such an event in 1054, which they called a guest star in the constellation Taurus. The supernova was 4 times brighter than Venus and was visible in daylight for 23 days. Centuries later, in 1781, the English astronomer John Bevis pointed his telescope at the constellation of Taurus and found this, a nebula that corresponds to the same position recorded by the Chinese and Arab astronomers, the remnants of the 1054 supernova, which is now called the Crab Nebula. Although science has demonstrated that these mysterious celestial events are natural, there are some people who still insist on seeing them as signs of impending doom. It's true that the universe can be a dangerous place. A massive asteroid impact is thought to have caused the dinosaurs' extinction 65 million years ago. About the size of 10 football fields, this asteroid slammed into the Yucatan Peninsula with the force of 1 billion atomic bombs, creating tsunamis a mile high. Today, there are people who claim that Earth is about to be struck by another celestial object. This time, much of the speculation is being placed at the end of the ancient Mayan calendar, which is supposed to fall on December 21st, 2012. According to some, this is the day that mysterious Planet X will arrive and wreak its havoc on Earth. But when confronted by the facts, the existence of Planet X simply evaporates. Astronomers haven't found anything even remotely the size of planet that could approach Earth in the year 2012. But the doomsday crowd is not deterred. CU Science Update's Jenna Browder takes a closer look at what fuels their predictions.
Ask some CU students about the 2012 prophecy and you get
the world's gonna end, or I don't know.
I don't know, what is that, like chicken or something?
The 2012 prophecy actually comes from the ancient Mayans, whose long count calendar ends in 2012. So how did this come to mean the ending of the world?
People need an Armageddon. They need some sort of doomsday.
Y2K, Halley's Comet, we've all heard of these prophecies that predicted the end of the world. 2012 seems to be the next prophecy in line. It's become popular for movies like 2012.
They're made to get people into the theater. They're not made to actually educate them.
Volcanoes erupt, grounds break, cities flood. While these events may make for entertaining movies, experts say the 2012 prophecy is no different from ones like Y2K or Halley's Comet.
It's not going to happen.
And if they're right, the year 2012 will come and pass just like the rest. Jenna Browder, CU Science Update.
Thanks, Jenna. Recently, CU Science Update's Priscilla Carlson spoke with Professor Emeritus Kim Malville from the Department of Astrophysical and Planetary Sciences. Professor Malville specializes in archaeoastronomy, a combination of archaeology and astronomy. He joins us in our studio.
Well, thank you, Professor Malville, for joining us. What we wanted to do is talk a little bit about archaeoastronomy. And can you tell us a little bit about it, what it is?
Well, it's a mixture of archaeology and astronomy, as the name suggests. But it's a way to explore the knowledge of astronomy of ancient cultures, what they saw as important for them in the heavens, often they found things that were very important because the heavens were filled with mysterious things, and they thought they were very powerful forces and spirits living there, so they paid attention to them. Especially the sun and the moon were very important for many of these ancient cultures.
And what would they do with that important knowledge?
Well, I was thinking the oldest site that I have studied is in southern Egypt, a place called Nabta Playa, and it was built by nomadic pastoralists in the 6,000 BC, who were cattle herders in the Sahara at a time when the Sahara was much wetter than it is today. And so the Sahara was filled with these bands of cattle herders who would need to navigate across the sands, much as ancient Polynesian navigators needed to navigate across the Pacific. And the Sahara has no major, most of it has no major features to head toward or go away from. So they needed to use the stars. These nomads needed to use the stars to find their way across the desert from one water hole to another. So it was very practical for these travelers. In other cultures like Chaco Canyon, for example, in the American Southwest, during the 11th century, it apparently was a major center for festivals that would be held around winter solstice, and people would travel for a couple of weeks to come into Chaco Canyon for these festivals, and they needed to know the date. They needed to know when to arrive in Chaco Canyon. Arriving too early means sitting around too long,
Yeah.
and smelling what is it, relatives who smell like fish after 3 days, and if they've missed the festival by a few days, there's no point having made the journey. So for these people walking into Chaco, they needed to have control of time. They needed to have a calendar that was that everyone in this whole community of Chaco Canyon agreed upon, and a calendar that could get them to Chaco at the time of, say, the full moon closest to winter solstice. That's probably when they had their festival. So astronomy for these people was important not only for navigating across the landscape, but also for having a calendar to time their festivals and other events that they felt important.
What type of instruments would they use to determine the time?
Well, for the people in the American Southwest, they used a very simple horizon calendar for many of the areas in Colorado and New Mexico and Arizona. There's a irregular horizon, and to the east and to the west, and people would observe where the sun comes up on that horizon. And as long as it isn't smooth, and as long as there aren't too many trees in the way, then they can commit to memory where the sun is at various times of the year relative to these peaks and valleys on the horizon. So these horizon calendars were sort of a built-in, very, very convenient calendar for many of these cultures. That wasn't true in places like Yucatan Peninsula, for example, for the Mayans. They were in the depths of a forest, and so they had no ability whatsoever to use this kind of calendar that was available in Chaco Canyon and Mesa Verde and Chimney Rock, places like that in the Southwest.
What did they use?
The Mayans, well, it's not clear. The Mayans built temples and they built pyramids. In Chichen Itza, there is a pyramid. There's a structure known as the Caracol, and it has a series of, it looks like an observatory. It has a series of windows at various areas, pointing out to various areas of the sky. And people would observe the appearance of something like Venus, for example, when it would move into those windows. So they needed to build artificial markers on the horizon in order to develop a calendar.
Okay, cool. And what can we predict based on the knowledge that you extrapolated from Nabta civilization?
What can we predict? You mean in terms of?
Are there any predictions or?
You mean the end of the world or something like that? Or what?
Yeah, what about this whole 20? I mean, is there like a 2012 according to the Nabtas?
No, I think this 2012 is pretty amusing because it's based upon the Mayan calendar. We were talking about
Right.
Mayan calendars. And we have our own calendar, and of course, and Tibetans have a calendar, Indians have a calendar, and every one of these calendars has times when you sort of tear off the page of a calendar and there's another month, or you have to throw away the calendar and get a new calendar. And so this 2012 event is simply a changeover in the Mayan calendar that should be happening all, every calendar has these kinds of events. So it's silly to worry about things like that.
So does Nabta have a certain date or a year or anything?
Well, Nabta Playa was built 5000 BC, and it has not only a calendar circle that would identify when June solstice occurred. And June solstice was important for them because the summer monsoon rains would move up from Central Africa into the Sahara around June solstice. And this lasted from about 9000 BC to 3000 BC. Then the climate changed and the monsoons stayed in Central Africa, and the Sahara became hyper-arid with no water at all. But for people living during this period of time, June solstice was the time when rains would come and depressions in the desert would get filled by water, and people could bring their cattle to these places for forage and for water. So June solstice was an event that was important to them, not because of any particular thing involving the sun, but because that's when the rains came. They also, in the Nabta Playa, is a basin of a large internally drained lake, and it would get filled during the 2 or 3 months of the summer monsoon rains. But then when it was dry, the people who lived there dragged large stones into the sediments of this lake using cattle. These are stones that were 10 tons or something like that, and set them up in lines across this at this time dry lake, and these lines were pointed to the brightest stars in the sky at that time. Sirius, for example, is the brightest star in the sky. There's lines pointed toward Arcturus and toward Orion and toward bright stars in the southern hemisphere. So these were probably the stars that these nomads used to help them navigate. But they were the brightest stars in the sky, and so therefore obviously very, very powerful and very important to them. And but then when the rains came, and this lake would be filled with water, you could still see these dark stones lined up above the water. And when a star like Sirius would rise on the horizon, you could see the reflection of the star in the water lined up with these stones. So for people standing on the edge of this lake, watching these important gods or spirits rising in the east, lined up with these monoliths, would have been quite dramatic and striking. This is the oldest astronomy that we know of. This is about 1,500 years older than Stonehenge and Newgrange, and it is surprising to many people that these were nomads rather than kings and priests, agriculturalists who had settled in like building pyramids or something like that. Mm-hmm. These were people who just came for a few months to this lake and then left their marks in terms of building this rather remarkable ceremonial center.
So how did you get involved in ancient astronomy? How did this become an interest of yours?
I am basically an astronomer interested in the sun, in solar flares and solar prominences and sunspots. And for many years, I was engaged in expeditions to view solar eclipses and to study the solar corona, which is a very sort of mysterious and hot atmosphere of the sun that can only be seen during eclipses. And during this period of time, I was very careful to choose places for observing eclipses that were interesting. I didn't want to go to well, I didn't want to go to, how can, I don't want to insult Georgia or Southern California, but I wanted to go to Africa and Peru and Brazil and places like that. So we had a series of expeditions to rather interesting spots in the world. One of them was to northern Kenya, where we were observing an eclipse on the edge of Lake Turkana, which is a big lake in the Rift Valley of Kenya. And we had a team of maybe 20 or so astronomers getting ready to observe the eclipse. And each of us were doing some very, very complicated and complex scientific experiments. I was particularly interested in why the sun's corona is as hot as it is, and why various types of gases are present on the sun. And then we were surrounded by the natives of northern Kenya, the Samburu, the El Molo, and Turkana warriors and their tribes. And we would walk down to our observing site every day, passing through these villages. And this mixture of just authentic African indigenous people, living their lives, and our study of these esoteric features of the sun was just extraordinary. And I was became more and more fascinated by ancient other people's belief in the heavens. What did these people in northern Kenya think when the sun was eclipsed, and what other ideas do they have about the powerful sun and moon in the sky? So that sort of triggered a lot of my interest in anthropology, and especially other indigenous beliefs in astronomy. But I also had been for many, many years teaching an introductory course in astronomy, and I very rapidly discovered that students in the class liked to hear these funny stories about not only Stonehenge, but about tribes in North Africa and the Mayan pyramids, and that turned out to be a really successful way of teaching astronomy to these in the introductory astronomy course. So it was a combination of discovering other people's knowledge and legends about astronomy at these various places around the world where we would study the solar corona and teaching.
What was the tribe's reaction to you coming into their land? And
oh, it was wonderful. When we walked through their villages, it seemed as though we didn't exist. The warriors would stand with their sharp spears and would not notice us at all. And it seemed as though we were two completely different worlds. But then once the eclipse had occurred, they came over to our camp and put on dances. and these people who at first had been so remote, a completely different world, as far as we can tell, became real people. And we had actually been rather scared of these warriors with their razor sharp spears, and we stood around and didn't quite know how to interact with them. And then one of our group asked to borrow one of the spears to try this party game of stepping through a broomstick without falling down. And so we borrowed the spear, and the guy stepped through the spear, and these warriors who have long legs tried to do that also, and they couldn't do it. They fell down on the ground and were just laughing like crazy, So these people who were at one time really difficult to communicate, we found ourselves all rolling on the ground laughing, holding their spears,
That's a great story. Another question that I had, so the ancient civilizations used the calendars, and it was like something that they used on a daily life to plan their events, yearly festivals and things like that. And it was a very practical thing. And now suddenly it's gotten blown up into this whole mythological 2012 end of days thing that people are believing in. It's kind of a phenomenon. How do you think we went from practical to mythological?
Well, I think every one of these other cultures have stories about the beginning and end of the world, And so even though their calendars were developed for solving their own practical needs, there was an underlying hint that the world was going to end in many of these cultures. And so it isn't too much of a leap when you consider Mayans or you consider the Egyptians to say, well, they had this calendar, but also they knew that the end of the world was going to occur. Why? It befuddles me why people are fascinated by the threat of the world coming to an end. You know, you'd think that's the least thing that you should be fascinated by, but we've had that all along. Of course, we have the Jupiter effect, where Jupiter and back in the 1990s, Jupiter and the various planets were presumably going to line up, and the combined gravity of the planets was going to cause tidal waves and earthquakes, and that never happened. I know someone made a lot of money by publishing a book called The Jupiter Effect, and then 2003 or 4, we had a planet X that was not visible. The astronomers didn't know about it, but other people did, and Planet X was going to come by and destroy the Earth, and someone made a lot of money with Planet X books. So I think it's driven by people. I'm not sure they are entirely honest. People wanting to draw attention to themselves and sell their books. But you know, we've had so many of these predictions in the past about astronomical catastrophes that haven't occurred that we have forgotten. But they do happen. Of course, we did have a comet 65 million years ago that hit the Earth and destroyed the dinosaurs. So if you want to worry,
okay,
you indeed can worry about that comet that kind of destroy humans as well as dinosaurs. But the likelihood is slight.
Good advice.
Isn't it amazing to think that people would go to all that trouble hauling and arranging massive stones just to measure the sun's position in the sky a little more accurately? We've come a long way since then, but studying the sky is no less important to us today. And new technologies are allowing us to learn more about the night sky more quickly than ever in history. CU Science Update Stephanie Bailey spoke with CU Professor Doug Duncan, Director of Fisk Planetarium, about his thoughts on how far astronomy has come since ancient days.
Almost everybody I've ever met has looked up at the sky and wondered, is there anybody else out there? We live at a time where astronomers have discovered planets around other stars. After hundreds, thousands of years of wondering, is there anybody out there? Is there other places to live like the Earth? We now know that there's other places to live. And maybe the next generation of scientists will find out, is there anybody living there? Here's something that astronomy teaches. It might be very valuable. The Earth has been here for 4 billion years. Human civilization has been here. Technical civilization that can do TV and radio and send signals has been here for 100 years. Ask yourself how long human civilization will last. Are we wise? Do we conserve our resources? Will we last for billions of years? Or will we use everything up on the surface of this planet in a couple of 100 years? Because if life typically did that in the universe, then civilizations would come and go just like little twinkling light bulbs, and they'd mostly be gone because they had not learned how to persist nearly as long as the universe. And so over the next couple of 100 years, that test will be faced by humans. Will we live in enough harmony and in a renewable enough way with our universe that we could last for billions of years or millions of years? Or will everything be used up in a few hundred?
That's all we have for today. Join us again soon for another edition of CU Science Update.
CU Science Update is produced by University of Colorado at Boulder, Journalism and Mass Communication. To download this episode and others from CU Science Update, visit the podcast section of the iTunes Store. or you can visit our website at cuscienceupdate.com. Finally, don't forget to like us on our Facebook page, where we post the latest in science happening in Boulder and beyond.